Good afternoon, and thank you for sitting in with us today. Today, we're going to be talking about application modernization with containers, Azure Kubernetes Services. My name is Clint Adkins. I'm responsible for our Azure practice here at Cortec.
My name is Brett Decker. I'm a cloud architect here at Cortec Services.
We're going to be going into introductions of what Azure Kubernetes Services is and an overview. We're going to talk about some scenarios today, some customer stories and how customers use Kubernetes and containers, looking at the open source culture that exists today, give you some resources, then provide some Q&A time if anybody has any questions. Please feel free to leave any questions you have in the chat window, and we'll handle those at the end of the webinar. So jumping into the introductions, before we really jump into containers, one of the key things that you need to have set up and enabled for your organization is a good Azure strategy and a good foundation. Microsoft's put together something called the Cloud Adoption Framework for Azure. And it's a really good start. There's a really good URL out there. We can provide it at the end of this webinar as a reference for you. It really outlines what your organization needs to do to be enabled for Azure and being able to truly be agile in the cloud space. So really defining what your business strategies are and understanding your motivations and objectives. What are your justifications? How do you prioritize your projects? How do you jump into your planning and understanding what your infrastructure looks like as a whole? How do you align your organization and ensure that they are trained properly and looking at your skills readiness plan? And then what is your actual cloud adoption plan? How are you going to move what you have today into the cloud, into Azure? Then once you have those things defined, jumping into actually doing the design and your actual Azure infrastructure design, understanding your subscriptions, your identity, your networking, your governance, your security, how are you handling all that from a best practices perspective? And then jumping into your actual landing zone and building your actual core Azure infrastructure to your standards and governance models. And then going into the adopt phase of migrating workloads or innovating. And we're going to really jump more into the innovation side today, talking about application modernization and how you innovate leveraging containers, and give you some foundational information about it and then go in deeper as well. Brett, I'll turn it over to you.
All right, great. So today we're going to be talking a lot about containers. So first, what I wanted to do is start to help everyone understand what are containers. And then after that, we'll go into a little bit more detail on how to orchestrate the deployment of these containers. So you'll see in this diagram here on the left and right side, there are two different infrastructure types. We have the containerized applications, and then on the right, we have a standard virtual machine IaaS, infrastructure as a service model. You'll notice on the right that you're seeing typical virtual machines that have applications and guest operating systems that need to be managed, sitting on top of the hypervisor, which in this case would be Azure. On the left side, you'll see the containerized applications are actually running through what's called Docker. So Docker containers are very portable. One of the benefits of them is that they can be hosted in many different platforms. And so you're kind of moving away from the operating system dependency when you're moving into containers. So each of these apps that are a container are standard units of software that packages their code and all of the dependencies so the application can run quickly and reliably from one computing environment to another. Containers are an abstraction at the application layer that packages the code and dependencies together. Multiple containers can run on the same machine and share the same infrastructure and host operating system. But they're each running an isolated process in their own user space. Containers take up less space than virtual machines. Their container images are usually less than a few gigs. And then they can handle more applications and require fewer VMs by acquiring a higher node density, by packaging many of these applications into a single virtual machine. So one of the tools that Azure offers is called Azure Container Instance. What's nice about Azure Container Instance is that is a single container deployment typically. They're easily deployable and can be run with a single command. They can launch these containers in seconds, and they're very cost effective by using per second billing rather than just how long the machine is up. But it's actually going to be, how much that you have this container instance running, how much time that it's actually consuming compute hours. So a couple more details on the container instances. You don't have to manage the servers. So that's one of the really good benefits, and starts to get into the app modernization side of things, where we're not spending as much time orchestrating patches for servers and security updates and different things like that. We increase the infrastructure agility. As I had mentioned, the containers can run on many different platforms, are very agile. And then you can secure the applications with hypervisor isolation as well. So that the containers don't necessarily have to be able to talk to each other, or they could talk to virtual machines if they wanted to, or external services. And continuing with that, there's no infrastructure to manage. They start and stop very quickly, as mentioned, and they don't have to worry about the operating system startup when the container is just running by itself. So when we're just talking about a single container, we would use the Azure Container Instance. But when we're talking about orchestrating many containers and providing an entire infrastructure worth of application or services, then we would look at something called the Azure Container Service, and the acronym is AKS, as it's commonly referred to. So the Kubernetes orchestration is key in starting and stopping containers automatically based on parameters that you provide to it. You can set up automated patching, automated scaling, automated updates. All can be done without any service interruption. And this is obviously deeply integrated with Azure development tools and services. So you can work directly with ARM templates, Azure CLI, Azure PowerShell, and use Azure DevOps for your continuous integration. So some of the driving factors for containers are density and performance. As I had mentioned, being able to put many containers onto a single virtual machine is going to reduce the cost there. When we start to abstract the operating system from the infrastructure deployment, we get to reduce the licensing costs as well. This helps enable a shift to DevOps by enabling manifests to only be updated by using a pipeline, which we'll get into a little bit more later. Scaling out is very important based on demand. The infrastructure may require additional containers, and we can enable that by setting up the AKS service. Faster deployment, since we're leveraging Azure DevOps and CI/CD, we're able to scale up many new environments very quickly with a single command. Some of the things that help understand where Kubernetes is at in the world today are shown here. 77% of companies who use the containers are using Kubernetes to orchestrate that, and that's mainly because those customers require that extra scaling and scale out and cost savings that they can get from the Azure Kubernetes service, rather than using just the Azure Container Instance. Gartner expects more than 50% of enterprises will run mission-critical containerized cloud-native applications in production this year. So we're expecting to see that as industries continue to modernize their apps, that they'll be moving to container instances and Azure Kubernetes service as they're doing so. These are some of the benefits as well. Again, portable, extensible, and self-healing, particularly the self-healing part where they can auto restart, auto replicate, and auto scale has a lot of infrastructure level benefits. But the portability as well is a huge business driver, because many organizations like to be able to know that in the future, as the technology continues to evolve, that they'll be able to transform and continue to adapt their service to the ever-changing technology. Here's a diagram of the AKS and Azure Container Instance. This is what it would look like at a high level of each of these pods, which are each of the containers running on the Kubernetes control plane. You can see here that we can actually connect the independent Azure container instances through an Azure Container Instance connector back to the Kubernetes control plane. So if we had one-off containers that we wanted to run, then we could still integrate them with the Azure Kubernetes service as well. All right, so we can always perform the automated upgrades and patches without any downtime, as Kubernetes is able to redeploy each of the containers automatically as soon as one of the updates is performed. High reliability and availability is enabled by using multiple regions. We can set it up so that these pods are spanned across multiple zones. And so that allows us to ensure that if a data center goes down, that all of our containers are still going to be readily accessible. And is a huge driving factor of the Azure Kubernetes service and the orchestration that is involved behind it. Easy, secure cluster scaling. The way that Kubernetes does security is mainly focused on namespacing. Many can draw a parallel to namespacing by thinking of a domain. A namespace is the equivalent version of a domain, and it allows us to run multiple namespaces on a single cluster. So if we needed to isolate multiple workloads or multiple namespaces from each other, then we wouldn't have to worry about any data crossing over on the same VM because there is a hard separation in the service level. Self-healing is important because we enable liveliness probes that tell us if the service is responding correctly from that container. If the service is not responding with an expected result, then Kubernetes will automatically redeploy the container, verify its health, and bring it up as it would starting fresh. API server monitoring is important for understanding all of the metrics behind the container orchestration and allowing you to get the most density out of your Kubernetes deployment and at the end of the day, the most cost savings for your business. And all of these features here are included at no additional charge with the Kubernetes service and are the real driver of modernizing your app here. All right, cool. So managed Kubernetes empowers you to do more. And what that really means is that the Kubernetes service is going to be taking on a lot of the typical responsibilities that your infrastructure team would have. So you'll see in this chart, the key there shows whose responsibility each of these tasks are. And with the do-it-yourself with Kubernetes, which in some instances is an on-prem solution. Maybe you have a containers running by themselves. And this is similar as well to an infrastructure as service, where you would manage all of the scaling, patching, monitoring, upgrades, hosting. You would manage all of that yourself. The AKS service allows you to abstract that and give Microsoft that responsibility, which is backed by a service level agreement. You'll see there that CI/CD is a split responsibility where You continue to provide configurations, but the back end is managed by Microsoft. And then containerization, many containers are available directly, but you can provide your own containers as well. So there is a split responsibility there. And then application iteration and debugging is shared responsibility, as if there's any problems, Microsoft is going to help debug and troubleshoot that.
Yeah, and I know we're talking a lot about Azure Kubernetes Services today and walking through that, but you can run traditional Kubernetes services on Azure, is that correct?
Yes, yep.
So you can look at different flavors of Kubernetes, whether it's OpenShift or one of the other ones out there, and run it inside of Azure. Today we're focusing on Azure Kubernetes Services primarily because of the slide. Specifically, there's no cost, no additional cost for you to share that responsibility where Microsoft owns that support.
Okay, great. So now we'll go into a little bit more of an overview of Kubernetes, and we'll continue discussing what some of those benefits are. So deploy and manage Kubernetes with ease, right? We have this free managed control plane for the automated upgrades, patching, self-healing, provisioning. We can be performed from the Azure portal or the command line interface, ARM templates, maybe a tool like Terraform as well. So really able to manage that Kubernetes, without any problems. Accelerate containerized application development. So we can rapidly iterate, test, and debug microservices using the Azure Kubernetes service, and so this helps us accelerate what that development would be, because when we see that all of the infrastructure side benefits, the investment in that development is truly a benefit to your organization. Set up CI/CD in a few clicks just by leveraging Azure DevOps and a DevOps project. We can work with existing tools such as Jenkins if we want to, and we can use a geo-replicated container registry as well in just a few clicks. Securing your environment or securing your Kubernetes environment is easily done with Azure Active Directory and role-based access control. We can finely tune what namespace someone has rights into. We can finely tune what infrastructure resources are allowed to communicate with Kubernetes. So there's a lot of options for security and role-based access control. When we're talking about keys and secrets, the Azure Kubernetes service will directly hook into the Azure Key Vault as well. So we can do things like automated key deployment, automated recertification of keys, and different things like that. When we want to talk about the networking side, we can create policies, network policies, that will only allow containers to talk on a specific port to a specific container. When we have 5 or 6 containers supporting a service, we may want to only allow one container to talk to maybe 2 of the other containers rather than having access to talk to all of them. So that's very easily done with a network policy in the Kubernetes service. All right, cool. So I wanted to give just a quick slide here to show you what some of the simple commands are. We can create a new cluster with this Azure CLI command here using AZ AKS create. You'll see that the old way has a bit more considerations that need to be made and a bit more prerequisites that need to be met, such as installing system components, registering agent nodes, and additional things like that. Upgrading a cluster and scaling a cluster is also just as easy as using a simple command rather than having to fight through other prerequisites. You'll see here that for the CI/CD side of things, it does greatly simplify the process that you have to follow in order to get your continuous integration started. When you can just simply create an Azure DevOps project with AKS as the target, you don't have to fight through building a repo and a pipeline, a container registry, a cluster, and all of that, as AKS handles it for you. Make the container images available for deployment worldwide is very simply just publishing to the container registry. You can set up geo-replication on the container registry with just a simple script or a simple click in the portal, which allows you that, that high availability and peace of mind that if a region goes down, then you'll be able to continue using all of your containers as expected. Tracking the health with consolidated cluster and application logs is as simple as clicking a checkbox for container monitoring in the Azure portal, rather than having to set up a monitoring solution on your own. You'll see here, all of these different open source options that will integrate with the Azure Kubernetes service as well. But do have Microsoft options that typically will simplify the deployment and use best practices for security and governance that Microsoft recommends.
Yeah, and we're not suggesting you just use the Microsoft tools. There are reasons to use some of these other tools, and Microsoft embraces that. So definitely don't shy away from leveraging existing tool sets like Terraform. So if you want to deploy to different types of infrastructure and be as agnostic as possible, feel free to keep doing that. Or you can leverage ARM if you're really primarily leveraging Azure.
Great. All right, so we'll talk a little bit more about securing your Kubernetes environment. As I had mentioned, we have Azure Active Directory and role-based access control. Typically what we'll see our customers doing is creating groups in Azure Active Directory and assigning the role-based access control roles based on the namespace that the customer is leveraging. An example, maybe we have a namespace that is for the corporate environment. So that would be used by the internal resources, but maybe we're also hosting a service that we're selling to another end customer, and we want that to be in a separate namespace. So we could have Azure Active Directory groups for the corporate side and for the customer side, and then those would be assigned to each of the namespaces in the cluster. What's great though is that we could have all of these hosted in the same cluster with this security. As I'd mentioned, we have key and secret security with the Key Vault. We have network communication security with the network policies. If we wanted to, we could put a firewall in front of the Azure Kubernetes service. We could use network security groups in Azure. So there are many different ways that we could bolster the virtual network security with the Azure Kubernetes service.
Yeah, I would add a lot of industry tools out there today have the ability to leverage container services, or specifically scan inside of container services. So an example is Tenable is one of the leading security products out there. Has the ability to specifically scan and make recommendations around security controls to put in place for containers. So you don't have to stop using some of the key technologies you have today.
Excellent. Yep, and then there are many different SOC, HIPAA, and other compliance regulations that the Kubernetes service is in compliance with.
Yeah, and reference Azure's compliance offerings if you want to see specifics around which compliance offerings it's certified with.
Okay, great. So we talked a little bit about security there, and as I had mentioned, our scale out is a huge business driver. As a lot of organizations, they may not be able to have a static infrastructure. They may have a demand that varies by by day of the week, by week of the month, by hour in the day. And these variations lead us to require auto-scaling to truly optimize the cost, so that we're not scaling to the highest common denominator. We're able to scale on an as-needed basis. So we can elastically burst the Azure Kubernetes service as that demand is impacting the resources. And we can use things such as the monitor, Azure Monitor, to keep track of how it's performing and adjust our scale as needed. And we can set up automation to adjust the scale so that it's hands-off until that you need more resources, and it goes ahead and spins it up. As I had mentioned too, the geo-replicated container registry is an important aspect. Helps us ensure that this is a highly available solution everywhere. All right, cool. So we'll go into some of the top scenarios for Kubernetes. At a high level, you'll see here, lift and shift to containers is an important one, and is what we're seeing a lot of the industries start to approach. This does immediately allow cost savings without having to necessarily refactor your app. Kubernetes allows containers that run on either a Linux or Windows-based kernel. And so specifically with Kubernetes, the orchestrator is based on a Linux backend, but we are able to use Windows-based containers. There is lots of more information that we can provide, and I can post a link at the end of this webinar about how that you would go about containerizing some of your applications and getting that package developed. Other scenarios for Kubernetes, microservices, so that you can develop your application faster with more agility. This is a huge business driver as release windows and release timeframes are reduced, so that you can spend more time on the actual application rather than on orchestrating its deployment. Machine learning. This is a great scenario for Kubernetes because of all of the scaling benefits that it has and the low latency that you get out of container services, because you're not necessarily dependent on the underlying operating system. You're running the code directly. IoT portability is very important because you can build once and run anywhere. As I'd mentioned, the being able to move from infrastructure to infrastructure is important, and that especially benefits IoT. You'll see here, as I was mentioning, the app modernization without code changes. You can speed the application deployments by using the container technology, defend against infrastructure failures with container orchestration, and increase the agility with continuous integration and continuous delivery. So you'll see in that little diagram there, you can take your existing application and package it, move it to the Azure Container Registry, and then begin using CI/CD to configure that and push production changes and continue to modernize that application, whether that be by integrating other PaaS services to work with it, or just configuring the scale and optimization. You'll see here some of the capabilities. Using the Azure Container Registry to store container images for your modernized application is a great benefit. Integrating AKS with Azure pipelines enables that continuous integration that I was talking about. Enhanced security with Azure Active Directory, as I mentioned, the groups and the role-based access control assignments. And then easy to access SLAs by the Azure-backed service and other Azure-backed services such as Azure Database for MySQL or any of the other PaaS offerings that they have. All right, so we'll go into a customer story here. One of our customers, iSight, is leveraging Azure Kubernetes Service, and some of their needs were to have a highly available, portable, secure, and scalable application deployment solution. So we had some challenges, right, with any application may, and so customer isolation was a huge one, where each of their customers must not be able to read or write data across the two. We were able to do this with the Azure Kubernetes service by using namespacing and the Azure storage accounts with file shares. Data migration was another challenge. They have a lot of data that is moving in AKS, and ensuring that that data is secured and meeting compliance requirements was very important, but easy to do with the AKS service as it orchestrates that data security on its own. Another challenge is limited organizational experience with Kubernetes. And as organizations are beginning to learn, this is going to be less of a challenge, but there's still going to be some time to get everyone up to speed. So that's why we're so glad that you're joining us today, and you're helping to kind of cross that bridge into the land of Kubernetes. Some of the requirements that iSight had were to spend less time on container management, where they had been leveraging containers in a one-to-one, one container to one virtual machine, and they were still having to manage those virtual machines with the container solution that they were leveraging. With Azure Kubernetes Service, they no longer have that one-to-one management, and that does reduce the amount of time that they have to spend on those. Automation and continuous delivery were very important to them, and being able to streamline their customer deployments down to a single script was something that greatly benefited them. Full visibility to application, container, and infrastructure. This is done with the Azure Kubernetes control plane and allows them to see how all of the containers are running and how they're performing, and what the network traffic is doing, things like that. And then lastly, fine-grained security and access control. As I had mentioned, their customers must not have any access between them, and we were able to do that with network policies and RBAC in AKS. All right, you'll see here, this is a high-level architectural approach that we leveraged here. You can see that they have a storage account at the top with file shares. You'll notice that these two tenants are leveraging the same storage account, but they have separate file shares. This helps support the customer isolation. And then you'll see all of this is running on a single iSight Kubernetes cluster. So it's important to see that we're able to acquire node density by stacking multiple tenants into the single cluster. And then you can see each of the apps that they have that are supporting their overall service, as well as the base Kubernetes system services. The namespaces here in this example are tenant 1 and tenant 2. And they provide the customer isolation, so those applications can't communicate across the colors. The containers across multiple namespaces run in the same cluster, as I mentioned. The Azure Monitor provides logging, troubleshooting, but has no direct container access, which is really important. And then, as I had mentioned, we have RBAC, so that each of these two tenants have separate access controls. All right, so the results from this have led us to reducing the environment provisioning time, cost savings, automated production deployments, less time spent on managing secrets, and increased developer autonomy, which has allowed their developers to focus on the actual application rather than on the infrastructure and the deployment. All right, so we'll get into open source culture a little bit here now. So as you'll see, there's been a lot of momentum in the open source space. Lots of applications and services are running on Linux. Lots of Linux virtual machines are running on Azure. And Microsoft has partnered with a lot of open source companies to truly get the benefits that everyone has to offer. So Microsoft contributes a lot to open source containers. They're the #2 overall individual contributor to Kubernetes, the #4 overall contributor to Docker and their containers. They're #1 through 3 overall contributors to Helm. And 70 Microsoft employees have made contributions to Kubernetes, the fundamental Kubernetes itself.
Yeah, I think that's important to really understand because Microsoft is all in on Kubernetes. And personally, I really believe that this is the direction of enterprise applications and where things are going. I think this containerization of applications, while it's here right now, will only scale significantly throughout all organizations.
Okay, cool. And so on this last slide here, we've got a number of different resources that can be leveraged, and we'll be sure to share out these links that help you kind of get a little bit more details on Kubernetes, answer any questions that you have. We're always willing to answer any questions you have as well.
I'd also add, if you are a Microsoft managed customer and you have a Microsoft account rep, you can leverage a lot of different funding programs from Microsoft to help get started through this process, and CoreTech can help you specifically help get an application or a few applications up into AKS, so you can actually start understanding how this works and have someone help you along the way. So please don't hesitate. Reach out to us if you have any questions related to that. Okay. And we'll give it a minute or two to see if there are any questions.
Sure. Hey guys, there's a question that came in through the chat window. First thing I'd like to say is thank you for presentations, very good. The question is, how is this different than a PaaS service? How do I think about Kubernetes differently?
Great question. Do you want to take that one, Brett?
Yeah, that's a great question. So AKS is a platform that you are providing a service from, but Kubernetes is primarily an orchestration tool rather than being the service that is being provided itself. Kubernetes is orchestrating each of your containers on a back-end infrastructure. So it does have some similarities to PaaS, but is providing mostly orchestration rather than the fundamental service.
So the way I look at it is, and I know this is a little bit less technical point of view than Brett has, but my perspective is containers is ultimately virtualizing applications on top of your operating system. So think app virtualization, but a different way for app virtualization, not in a traditional manner. And Kubernetes, or Azure Kubernetes Services, is the orchestration tool that manages those applications. Now, inside of those virtualized applications, they could have platform services running or PaaS services running, like SQL, Microsoft Azure SQL services, MySQL services, Azure App Services, so like web services and things like that are true PaaS services could be running on top of the Kubernetes service. So hopefully that answers your question out there.
Great. I did have one additional one here. How do I decide where to start? This sounds like there's a lot here to think about. What are the considerations, or is there questions that I can ask my organization to get the right pilot started?
Yeah, that really is a great question overall. I definitely recommend two key things. One is go through the CAF, or the Cloud Adoption Framework, to really understand how you're going to be leveraging Azure as an organization and how you're setting up your company for success long term from a security and governance and just making sure you're set up for long-term scalability with it. But then, assuming you've gotten past that stage, I definitely recommend starting to lift and shift certain applications into container services. I think that is a good place to start. Brett, do you have any other thoughts?
Yeah, no, that's definitely a great place to start. Having the fundamental understanding of how you're leveraging Azure is important, and understanding to the Microsoft tenant and the Azure Active Directory is a good place so that you can ensure that you're starting with good governance. And then as you start to move into each of your services that you're providing, then you have to start by assessing the viability to run in a container, and then whether that container needs to be orchestrated or needs to run on its own. But I think that overall, the best place to start is to get a fundamental understanding of Azure. And then from there, you can help decide what the best, most efficient tool for your use case would be.
That's a great point, Brett.
Great, and then there's one additional question. What type of ROI would I expect from something like this? Is it going to be focused on infrastructure, people, process? How do I start thinking about that?
Yeah, great. Another great question out there. Thank you. I think from my perspective, I think there's multiple aspects of it. You definitely get a direct ROI when you're looking at containerization and being able to map multiple applications, virtual apps, so containers on a single VM or single node. You're definitely able to get a lot denser. So there's clear ROI from that perspective. That's very tangible dollars right there that you can save by going to this type of service. If you have an application that runs on 40 servers, it might run in a container services on 10 servers in a container-based platform. It really depends on your application. Don't use those numbers for your ROI, please. It's not what I'm trying to say. But just know you can significantly reduce your actual tangible footprint. But then I think the bigger part is, as you continue to modernize your approach to your organization, and you start using things like Kubernetes, from a people and process perspective, you can save a significant amount of money. You can test things a lot quicker. So you can roll out new code quicker and easier without having to test a full pilot of infrastructure to a lot of different individuals. It truly is a big step in getting you to be more agile and really be able to save a lot of time from a process and people perspective. Any other thoughts, Brett?
Yeah, and going right along the lines of the people and process, the day-to-day management of the infrastructure can, in some parts, be abstracted from that. And so if you spend a lot of money on maintenance or your infrastructure, this may be a good solution for you, that you can configure maintenance automatically, and you can configure self-healing automatically, so that you don't have to spend as much money on resources to take care of those things for you.
Thank you both for your time. I know we went a little over, but I think it was well worth the few minutes spending on the topic. Recordings are available on www.coretech.com under our videos section. All other events, if you would choose to, are under www.coretech.com/events. Please join us for additional conversations. Thanks for joining us for Tech Tuesday.
All right, thank you everybody for your time.
Thank you.